Page 14 of the C programming notes, and we're getting near the end here. I'm going to talk a little bit about the tool chain. So this is kind of classic systems programming knowledge. So I'm going to show you how to, what happens when you compile a multi-file program, or a program that has multiple source files. And in this example, we're going to have 3 source files. So main.c, and retarget. So these are source files that you might create in Lab 0, for example, or Lab 1, and the other C file was uart.c. Okay, so we got 3 source files. We're going to compile them, and they're going to get turned into something that you can execute, and there's a bunch of steps in the middle. So the first thing, we just covered this in another section, the preprocessor. It does the text transformations on your source file, and so it will depend on your tool chain what the preprocessor is called, but it's often called the C preprocessor, CPP. And so each of these are going to go through this. And I need to squeeze this a bit. It's going to easily take up the width of the page. Once it's been preprocessed, it's going to go through the compiler, which will do a lexical analysis. It will identify tokens in your program, so those are identifiers, keywords, brace brackets, that kind of stuff, and it produces an abstract syntax tree of all this stuff, and then it can do optimizations on that, and then it can emit assembly code, and then that assembly code can be assembled and turned into object code. So the next step is the C compiler. So the GNU C compiler is GCC. The original Unix C compiler was CC. There's other flavors out there. So that's the next step, and then they will generate assembly code, which needs to be assembled into machine language for the specific processor that you're working with for the target. So there's our assembler. The GNU assembler is GAS, GNU AS. And so the assembler spits out, or produces, I should say, object code, which is machine instructions in a file. And so if you look, there is an objects subdirectory in your Microvision Microvision 5 project, and you should see some .o files like main.o, retarget.o, uart.o. So these are not human readable, they're binary, and they also cannot run on their own. So for example, main.o, it will have a main function, but what calls your main? And it's the C library that does that, and so that needs to be added to it. And also in main, you'll probably call things like printf, which will then call other functions that are described in retarget.o and uart.o, and so those all need to be linked together. So they'll have external references to functions and variables that they need, and so those all need to be connected together. So those are all going to be brought together by the linker, which is confusingly called LD, as in loader. So linker and loader used to be one tool, now they're separate. So that's the loader, brings all that together, including library objects and there can be several of them that get linked together, and that all becomes your executable. So executable. All right. So we've got, that is the preprocessor, the compiler, the assembler, this is the linker. And so normally, like on a desktop or laptop or whatever, you end up with, if it's Windows, you end up with a .exe file. If it's Linux or Mac OS, you'll end up with something in the ELF format, executable something something. Anyway, it's in a format that the operating system understands and can load into memory and start running that program. For us, it's turned into yet another format that then gets loaded into memory on the boards and then run from there.